All right, so I think I'm recording. Let's take a look. We're in this Skill 8F, and we're on these first few problems of our practice. We're verifying trig identities. They want us to prove, to show one of the Pythagorean identities, that 1 plus the cotangent squared of theta is equal to cosecant squared theta. Now remember, if we've already proven an identity, we can use it in this new proof. And in class today, we illustrated that sine squared of theta plus cosine squared of theta was equal to 1. So what if I start with that? If I start with the sine squared of theta plus the cosine squared of theta is equal to 1, since I know this to be a true identity, I could treat this like an equation, and I can use my properties of equality. I can't yet say that these two are equal to each other until I've proven it. So I can't use my properties of equality, and if I try to start with either the left-hand side or the right-hand side, I can't make the claim that those are equal yet. I can make the claim that these are. Now let's divide both sides of this equation by sine squared of theta. So if I divide the left-hand side of this equation, then to balance the equation, I need to divide the right-hand side. So on the left-hand side, I have a single fraction. I know this denominator that I can split this up, and I can take this first term. It gets divided by sine squared of theta. And I can take this second term, cosine squared of theta, divided by the sine squared of theta. And I'll just leave this one alone for a second and not do anything with it. All right, now, what do we have here? On the left-hand side, sine squared theta divided by sine squared theta is 1. And cosine squared theta divided by sine squared of theta, I can write that as cosine over sine of theta. And since the numerator and denominator are being squared, I can write that exponent out there. And I can do the same thing over here with 1 over sine squared of theta. Write it as 1 over sine theta quantity squared. Now, when I look at my definitions, I can use, well, let's see. Let's go ahead and use not only the identity, the Pythagorean identity, but let's use one of these quotient identities, that the cosine of theta divided by the sine of theta is equal to the cotangent of theta. Okay, so I know that this guy is the cotangent of theta from that previous identity. 1 over sine of theta, by definition, is the cosecant of theta, and that's being squared. And we've already seen the notation of when we square these trig functions and how we write it, that we write this as 1 plus the cotangent squared of theta is equal to the cosecant squared of theta, which is what we were trying to show. Okay, now we have to, in our proof here, we have to validate, we have to say that we've already proven this Pythagorean identity and this quotient identity. If we haven't done that, let's do this problem again, assuming that we haven't done that. Let's be a little more of just down to the roots basic definition. So suppose I haven't proven this yet, or maybe I simply don't think of it when I'm trying to construct this proof. Alright, so if I were doing this, I would start with the left-hand side because it's more complicated than the right-hand side, and I would try to simplify these two terms to be a single term. So I know that I can express the cotangent of theta as x divided by y. That's how we define that ratio. Okay, and I know that this exponent of 2 there means that I have x over y times x over y. I know that I can write this as x squared over y squared. I know now if I want to combine these two terms, if this is a fraction, I need to rewrite the number 1 with a denominator of y squared so that it has a common denominator. So I've got y squared divided by y squared, which simplifies to 1, and x squared over y squared. And now, since these are the same denominator, I can write these two fractions as a single fraction. My numerator, oops, I'm so used to writing the x first. My numerator is y squared plus x squared. And if I look up at this right triangle, from the Pythagorean theorem, I know that if I take the sum of squares of the lengths of the legs, that's equal to the length of the hypotenuse squared. So I know that I can replace this numerator of y squared plus x squared, I can replace it with r squared. And I know, let's continue over here, I know that I can write this fraction as r over y quantity squared. And I know that r over y is the definition of cosecant of theta. That's how we define this ratio of cosecant of theta. And when we have these exponents, we write it as cosecant squared of theta. So I started with the left-hand side and illustrated that I have the right-hand side. And here in this derivation, I didn't use any previous identities. I just used the definitions of our trig functions and just common properties of arithmetic of rewriting the number 1 and adding fractions together with a common denominator. So hey, I hope that helps, and I'll talk to you later.